see all of you here, and it's always a pleasure to welcome all of you and be your host for this event tonight. So I'm going to start off by acknowledging the traditional custodians of the land in which we meet today and pay my respects to the elders past, present, and emerging. Welcome to all our alumni, the guests, members of the Faculty of Science, and also students who are here today. So I'll give a bit of a format of tonight's event. So we'll have a bit of an update from the Dean of the Faculty of Science, and then we'll move on to the panel session, and then the Q&A where you can ask your questions, and I'll give a bit of an update on our engagement with our alumni, what programs, etc., and then move on to the networking session afterwards. So there's plenty of time for us to chat afterwards as well. So let me start off by inviting Professor Jordan Nash, the Dean of the Faculty of Science, to give a bit of an update on the faculty and tell us what's happening there. Put your hands together for Jordan.
So I would also like to acknowledge the people of the Kulin Nations on whose unceded lands we are gathered today and pay my respects to their elders past and present. And I would like to welcome all of you, as Udi has done, to this event tonight. I'm going to give you a little bit of, I've been told to tell you about what's going on in the faculty, so I will do that, but I will also take this opportunity to thank you for your engagement with us tonight. The topic that we have tonight has got weather and climate in the title, and those are things that are really, on all of our minds these days when we hear about climate change, and then we hear about extreme weather, and the climate scientists, Allie will say, weather is not climate, and they get really angry if you try to mix those things. But then they went to the ARC and said, we want a center of excellence on climate that's got weather in the title. So we'll hear about how they managed to pull that one off, but I do want you to remember that studying the climate is vitally important. Understanding its impact on the weather is something that will have real impact. And this is one of the things that the university as a whole is really keen to do, and that nobody reads university strategies, but I'll tell you what it says. It says impact is the main title in it, and it's about trying to tell all of you in the nation, in the world, that the things we do at universities aren't just esoteric, but they also have real impact. So we do universities do a wide range of things. That's what, universe is in the name university, and that speaks to the breadth of what we're able to do. But we do some things at incredible depth. I studied subatomic particles, and it's a really narrow, specific field. But we also bring together people doing activities at this huge range of breadth with incredible depth, and that gives us an ability to look at problems in a way that really there isn't any other place that can look at the problems in that particular lens, bringing that talent to bear. And so there's a real place for universities to tackle some of the big challenges that we see, and that's one of the things that our university has identified. Monash has said, well, let's try to tell the story about how we do that with three big challenges. The first one is climate change, and we're going to hear about that one tonight, and it's an obvious one. The other two bring in many big important things at the university as well. So they're healthy communities, that's talking about, again, how we live in a healthy way, how our urban environments work, how our environments work in the face of climate change, health challenges and aging. All these things are part of how our communities need to remain healthy, and they're places where universities can come together to solve. And the last one is geopolitical security, which again is on all of our minds. And so many things affect that: food security, energy security, political issues. And again, the university has people across all of these domains which are studying those types of problems and able to provide impact on our society by bringing together people who can really bring their insight on a wide range of topics and talk together. So in our faculty, there's one that of these three challenges that really speaks to what we do, and we have input to all of them, but climate change is something that's really squarely in our wheelhouse. And we've worked really hard to try to become both a national and internationally recognized place to study these, the effects of change on the climate. We have two really big national centers which we've been awarded over the last few years. So the first was one, and some of you will have come to Stephen Chown's talk about the Antarctic. So that was the Securing Antarctica's Environmental Future. That was a big national research initiative. So that's leading Antarctic environmental research for the nation. And this year we have secured in Australian Research Council's Centre of Excellence on weather in the 21st century. So this we'll hear a little bit about tonight, and this is a really important, big initiative, and it's one of the really big new centers. Again, it's a national center, and we are leading that center out of Monash Faculty of Science. In addition, we are doing other pieces that line up with this change. So Allie, who's going to talk to you tonight, is one of the leaders of the new Faculty of Science Climate Science Center, which is looking to bring together activities in climate science across the university. So bring our expertise together with those in law or IT or engineering, trying to bring people together to help attack the problems where climate change is having an impact on many different things. Another thing which the faculty is doing is in the area of critical minerals. So we have a lot of expertise, and we're working with the engineers to try to understand how best we can use our expertise to work with industry and the nation to develop strategies for extracting critical minerals, using critical minerals, finding critical minerals, cleaning up after we've dug up critical minerals. So all these things, critical minerals are going to be important in many of the solutions we have for transitioning our energy usage, and understanding how we find them and use them and mitigate them is going to be really important. So I think that's just a taste of some of the things that have been going on. We're doing lots of other things which go across a wide range of activities. We've had lots of success with grants from the research councils and with awards, and I do think that you can go to our website and read about those things. I don't want to spend 10 minutes doing that now. We're going to focus today on what our interaction is tonight on climate change, but I do want to say a few things about what I do want, the challenges that we face, and how alumni are a really important part of our moving forward as a faculty. So you all had a chance to sit in classes in science in Monash, and that formed some part of you as a professional. Some of you have moved on. Many of you, I think, have moved on and are not actively doing what we would call science in your careers, or you're doing something that's science related, but you've moved off into another discipline. That isn't necessarily something we're doing, but it's, when I come and talk to you and meet you at these sort of meetings, I get a taste of the types of things people do. And it's really clear that a lot of the foundations that we teach, the scientific method, the critical thinking, really remain important to you as you go forward in your careers. And we want to make that message known to the students who are coming through now. And we want to get your expertise available to the students to learn about what they can do, how your journey's been in your career, what type of things you've learned, and what are the careers available, and what was useful, what wasn't useful about what you studied, what they might concentrate while they're here. A bit of mentoring, or just a bit of getting to know what's out there, I think is really important for our students. Also, we want you to know what we're doing, how effective it is, but also the struggles we're facing. So you could probably read the newspaper, and maybe you do or you don't know about what's going on with political happenings with universities. This is a continual cycle with whether universities are a good thing or a bad thing, whether we need international students or we don't. These are political issues, but the truth is universities are a really important part of our society and of the society, the future for our children, both in training them and helping to create a place where we can have people trained to do the future-looking types of things that this nation will want to have. And I think your advocacy and saying, just, recognizing, actually, it's worth it to support universities. We don't need to put the boot in because we can see that they're doing this or that. And I welcome any support any of you can give when you hear people slagging off the universities. Remind them, actually, some good things came out of university and will continue to do so. And it's a really important thing for the nation. I know it's not like I'm singing for my supper here, right? I'm singing for my children's future. I'm really thinking about this is, universities are a cornerstone of society, and we need to support them. I'm almost finished. Udi gave me a bunch of numbers. So we do connect with alumni. We have about 10,000 of you click on our newsletters a year, or get about 4,500 get involved in some activity. 1,200 of you actually go to a webinar or come to one of these events. About 500, more than 500 of you volunteer to be mentors. About 150 of you came to our industry week, and about 400 of you have actually opened your checkbook and given us some money. So I want to thank you to all of you who've participated in any of those activities. I hope they've enriched you, and I assure you they have enriched us. So with that, I am going to thank you, wish you a very lovely evening tonight. I hope you enjoy the talks, and I'm going to return you to Udi's care.
Thank you, Jordan. Okay, so this brings us to the anticipated presentation session, The Weather and Climate of the 21st Century, What to Expect and How to Adapt. Gosh. So for that, I'm going to introduce you to the moderator for this evening, Sugata Narsey, who has done a PhD with us. He's one of our Monash alums. So just a little bit of an introduction to Sugata, and then he will kick off this session afterwards. Sugata is very eager. He's just about to come here. No, just a minute, Sugata. So Sugata Narsey is a climate scientist working at the Australian Bureau of Meteorology, moderating this panel tonight. Sugata's completed his PhD in 2017, I should say Dr. Narsey, and he's currently working on developing next generation of regional climate change projections for Australia, with a particular interest in how tropical rainfall may change due to global warming. So put your hands together and welcome Sugata for moderating this session.
Thank you. It's my great pleasure to be here moderating this panel tonight. I'm not sure who decided to let me in. You can call me Sugata. My dad was Dr. Narsey, so I prefer to just be known by my first name. Okay, so this is a really important topic, and it's something that I'm very passionate about, something I work on every day at the Bureau of Meteorology, and it's my great pleasure to introduce the panel. I'm very sorry to inform you that Professor Christian Jackob is not here today. He was a bit unwell, so he couldn't attend, but Allie will be giving his talk in his place. Okay, so without further ado, I'll introduce Associate Professor Allie Gallant, who I've had the good pleasure of knowing for quite a few years now. And Associate Professor Gallant is a Chief Investigator at the Centre of Excellence for 21st Century Weather. She leads the Weather Resources Project, studying Australia's weather reliability in a warming world. Her passion for science education extends beyond the classroom, and she actively engages with the media as a science communicator, frequently appearing on programs like Melbourne's 3RRR science show Einstein A Go-Go, which some of you may have listened to once in a while, and ABC Radio Melbourne, where she regularly features. With over 15 years devoted to studying Australian droughts and extreme weather, Allie is also a recent recipient of the prestigious Dorothy Hill Medal in recognition of her contributions to earth sciences on groundbreaking research on weather changes during droughts from the Australian Academy of Science. So I'm going to welcome Allie to the stage to come give a presentation. I'll let you know when it's 4 minutes, and I'll let you know when it's 7 minutes, as we discussed. And if you have burning questions, please try your best to hold on to them. We're going to have Q&A at the end after all the 3 presentations today. So thanks. Please welcome Allie to the stage.
Great. Thanks, Sugata. So I'm going to moonlight as Christian for the first talk of the evening. So I do apologise. I've only seen this talk for the first time this afternoon, but I'll do my best to get through it. So first up tonight, we want to talk about climate change. And make no mistake, our climate is changing. I'm sure many of you in this room are well aware of that. And you're also well aware that we are responsible. We're responsible for this changing climate. And when we think about global climate change, we often think about just that, global climate change. We think about increasing temperatures, and we think about things like this graph on the top left here, which shows how global temperatures have changed from 1950 and how they're expected to change in the future. So from that graph, there's a few things that pop out to us. One, we know that the world is warming. We also know that in the very near term, there's not much we can do about that. It's going to continue to warm. But in the long term, one of the interesting things you see there is we have choices. We decide how much this world warms. That's in a global context. We also see other climate changes as well, and that's shown on the bottom image there. The bottom image shows the changes in the intensity of extreme high precipitation events or extreme precipitation events. So a 1 in 10-year event and a 1 in 50-year event. And you can see that as we move up the global warming scale from 1 to 1.5 all the way up to 4 degrees, we know that the atmosphere can effectively hold more moisture, and that tends to lead to more water being squeezed out of the atmosphere and high precipitation events. But when we often see these things, we see them at a global scale. And I'll talk about that again in a second. But one of the other things we know is what I spoke about before. And for once, we actually have a very elegant and simple solution in science. And that is that the cumulative amount of greenhouse gas emissions that we emit in this world dictates how warm we will get and the magnitude of the climate changes. The relationship is surprisingly simple, as shown by that graph there. It's almost a straight line, apart from the wiggles that you see, which is what we call natural year-to-year variability. Some years are just hotter than others, some years are colder than others, things like that, due to things like El Nino, La Nina, which you may have heard of before. But we see this simple relationship, and so the point here is we know this connection between global temperatures and cumulative carbon emissions, and for things like high precipitation events. But that's global. But as we move forward, the wicked part of the problem of climate change, well, there are many wicked parts to it, but one of the biggest wicked parts is that how climate change is manifest on the regional and local scale is a much more difficult problem than that nice straight line graph that I showed you in the previous picture. But of course, this is the type of information we need, and we increasingly need it. Some of you might be aware of the recent climate-related financial disclosures that are now required by organisations and businesses and government across Australia to tell us how exposed they are to climate change. And this is not just in Australia, this is happening around the world. As we move towards a world of net zero, we are going to start becoming much more reliant on the weather as we move to renewable energy resources, which largely depend on the weather, and I'm going to talk about that later. Wind, solar, hydro, all those things, we need to know at a much more granular level how the climate and indeed weather will change. And of course, adapting to changes that already exist and changes that will inevitably happen with climate change. For example, I'm sure you are well aware, given the last 10 years in this country, at how extremes impact both the Australian climate and, of course, we've seen recent examples around the world, particularly with the Northern Hemisphere summer. And as I said, this requires that localised, granular information. That's a little bit of a problem with climate change and with what we know in the science, because that is where, unfortunately, the biggest source of uncertainty lies, hence it becomes a much more wicked problem when we get down to that granular level. So getting this information is really hard. I'm going to show you why it's really hard using this example of rainfall. So on the image on the left there, that's an image of the observed, what we call annual average rainfall around the globe. So just the average across all years. So the bluer the colours, the higher the average, the whiter the colours, the lower the average. You can see that in the tropics, around the equator, that's where we have the highest average rainfall as we get kind of, tropical storms and tropical convection dropping a lot of rain. It's very warm there. The air can hold a lot of moisture. Down it goes. You can also see the whiter areas that cover the more desert regions, Australia being one of them. And you can see that distribution of rainfall across the Earth's surface. Now, this is, as I said, annual average. We can also see on the right what we call the projected changes in rainfall, with, in the top left, 1.5 degrees of warming, 2, 3 and 4 on the bottom row there. And you can see that there's all sorts of different changes going on, but the one thing I want you to notice is I want you to look on those plots if you can see the areas that don't have the lines across them. Because those are the areas where we have confidence that the changes will actually happen. There are very few of those areas with no lines on them. The areas with the one line show either no change or not a robust signal, and the areas with the crosses on them show conflicting signals depending on which climate model we look at. So we have quite a lot of uncertainty here, largely because rainfall is so variable from year to year, it's hard to detect a signal. But we need this information, as we said, on that small scale. So why do we get this kind of uncertainty at this local level, particularly with something like rainfall? It's because rainfall isn't actually an average quantity. We tend to think of it as something that's accumulated, but the reality is this is how rainfall's made. This comes from a satellite image, so this is a little video that's been put together from several days of satellite images, and it shows rainfall across the globe. It's not just big blobs. It's constantly moving in blobs of different shapes in different directions. In the tropics, you see it's moving from east to west in these kind of concentrated little circles or blobs. In the mid-latitudes, in both the northern and southern hemisphere, you can see the familiar look of fronts and these kind of big rivers in the sky, which Kim will talk about in the next talk. But you can see that when you've got a lot of rainfall falling, that might add a lot to the annual average, as opposed to just a little front that doesn't have much rain. And in fact, some of the research that we did in my research group showed that, for example, the difference between making and breaking a drought is just a handful of heavy rain days in a year, maybe about a week's worth of rain. So this is where the ARC Centre of Excellence for the Weather of the 21st Century comes in. And I'll show you a video which will hopefully explain what it's about.
We all have our own vision of good weather and not so good weather. But when you hear or see the term climate change, you might think of weather like this. Yet climate change isn't more than just the extremes. Climate change is weather change, and we need to understand it so that we can harness weather as a resource and can better mitigate and adapt to high-impact weather events. Something Australia's leading climate and weather researchers aim to achieve at the new Australian Research Council Centre of Excellence for the Weather of the 21st Century. We are a consortium of 24 organisations led by Monash University, in partnership with the University of Melbourne, the University of New South Wales, the Australian National University, the University of Tasmania, the Bureau of Meteorology and CSIRO, as well as 8 international research centres, 3 government departments and 5 private companies. We are funded by the Australian Research Council for 7 years with $35 million and an additional $10 million from partners. Through our highly integrated research program, we will advance the understanding of weather-climate interactions and build the capacity to make actionable predictions of weather change for Australia. We will also transform Australia's weather and climate research capability by developing ultra-high resolution climate modelling. This all alongside our strong focus on societal impact that will enable Australian businesses, governments and communities to make evidence-based decisions related to weather change. This is furthered by our dedicated training and leadership program that will create the first generation of weather change scientists. The research themes of the new centre: circulation change, weather change and modelling science. By advancing our collective understanding of weather change, weather resources and high-impact weather, we will equip Australians with the tools and knowledge to meet the challenges and opportunities ahead with confidence. Therefore, we are proud to present the new Australian Research Council Centre of Excellence for the Weather of the 21st Century.
Thank you.
Thanks, Allie. All right, so our next speaker is Dr. Kim Reid, and Dr. Reid is a research associate at Monash University School of Earth, Atmosphere and Environment, focusing on rainfall patterns, their causes and future changes, and extreme weather events. She's a dedicated science communicator, and you may know her from her regular appearances in the media talking about climate and weather to broad audiences. She has a very good following on Twitter. She even performed a climate science stand-up routine at the Melbourne International Comedy Festival. So, Dr. Reid also contributed to New South Wales and Victorian government flood inquiries, and today she will provide insights into extreme weather events and their potential impact on Australia, helping us prepare for the future. Please welcome Kim.
Thank you, Sugata, and good evening, everyone. It's wonderful to be here today. So I'm going to talk about the February and March 2022 floods, which you may know of as the Lismore floods. And if you don't remember these events, if you weren't watching this relentlessly like us scientists were, I'll give you a quick refresher. So this end of February, early March 2022 was characterised by unrelenting rainfall and widespread flooding. From the 26th to the 28th of February, Brisbane experienced 3 consecutive days with about 200 millimetres of rainfall. In other words, they received about Melbourne's average rainfall in 3 days. On the 28th of February, the Wilsons River near Lismore peaked at 14.4 metres. That's 2 metres above the previous record. These floods didn't just beat records, they decimated records. And this, of course, led to a lot of devastating impacts. In New South Wales, 9 people lost their lives, 14,500 homes were damaged, and 5,000 homes were deemed uninhabitable. People sought refuge on the roofs of their houses in the middle of the night and were rescued by their neighbours in tinnies. Over 2 years on, many communities are still rebuilding. So this video is just showing a radar image of the event that happened, and what you might notice is that blob of, I'll play it again if I can, yep, that blob of rain that just stayed on that southern Queensland, northern New South Wales coast. It just stayed there for about 3 days. And as a result, the weekly total rainfalls were quite phenomenal. So those purpley coloured regions show areas where the weekly total rainfall exceeded 400 millimetres. One of the benefits of being a part of a centre of excellence is that we can quite easily collaborate with a lot of people. So following this event, myself and 20 other scientists who are predominantly early career researchers undertook a large evaluation of this event to try and understand it from a whole lot of different perspectives. There were 20 of us from 10 different organisations around Australia, and these are the results that I'll be talking about today very briefly. So this here just shows a weather map of the 28th of February, and those black lines show the mean sea level pressure, or the isobars like you would see on the weather map on the evening news. And the coloured regions show the amount of water vapour moving through the atmosphere. So that's the amount of water vapour in kilograms moving over a location every second. And there are a few things I want to draw your attention to here. So the first notable feature is this giant blocking high pressure system to the south and southeast of Australia. And this blocking high pressure system sat there for about 3.5 days. So normally for southern Australia, weather moves from west to east over the southern part of our continent. But when you have this high pressure system stuck there, it means the weather can't move on. And that's why we had that rainfall falling for about 3 days non-stop. Another point of note is that in the southern hemisphere, air moves anti-clockwise around a high pressure system. So that meant that there was this continuous flow of onshore, moist, warm air from the Coral Sea hitting southern Queensland and northern New South Wales. And you can see that by the coloured purple region on the map. And this narrow region of high water vapour transport is called an atmospheric river, and they're so named because they carry a similar amount of water to the Amazon River. And what's not shown on the map, but I can tell you, is there was a trough or a region of low pressure. And what low pressure does is it helps air to rise, and when water vapour rises, it condenses into a liquid and therefore falls as rain. So you effectively had an atmospheric river, like a hose, pointing at this low pressure system, which forced the air up and turned that hose of water into rain for about 3 days straight. In addition, and this is about to get complicated, this slide, but I'm doing that on purpose, and you'll see why. In addition, the past 2 years we had a La Nina, which is associated with increased rainfall over eastern Australia. So the rivers and dams in these regions were already quite full before this event happened. And another, what we call climate driver, is called the southern annular mode. So you can think of that as like La Nina and El Nino in the Southern Ocean. And it refers to the north and south shift of winds that whiz around Antarctica. And the southern annular mode was in its positive phase, which means the winds were closer to Antarctica. And what that does, that southward contraction towards the pole, means that warm tropical air can then penetrate south into New South Wales. So the positive SAM is also associated with enhanced summer rainfall over eastern Australia and also an increased chance of blocking high pressure. So what I've hopefully made clear is that an extreme rainfall event usually isn't just one thing causing it. It's usually a combination of a whole lot of factors that come together and, excuse the cliche, but create the perfect storm. And that means when scientists are asked, well, what's going to happen to rainfall in the future? We can't just grab the rainfall data at Brisbane and plot that on a map. We have to take into account how all of these different features of the weather and climate are likely to change. And they don't always do the same thing. So scientists are quite confident that the amount of water vapour and moisture in the atmosphere will increase as the planet warms. We're a lot less confident about how blocking high pressure systems might change over time. And the southern annular mode, for example, varies depending on what season you're in and what state you're in. On top of that, weather doesn't occur in isolation. There are intricate relationships between each of these features that we have to understand if we want to know what's going to happen in the future. So in summary, understanding future climate risks requires us to understand these weather systems. But there is a lot of great research happening. For example, developments in computing technology means we're just starting to research extreme weather events in much higher detail than previously before. So this map I showed, it's actually produced from a model with a resolution of 2.2 kilometres. So think of a whole map of Australia with little pixels like your TV, and each of those pixels is 2.2 kilometres wide. That's how much detail we are getting. For comparison, the latest round of climate models typically have about 100 kilometre pixels. On top of that, there are new global research programs that are aiming to improve our observations of these heavy rainfall events, because we need those observations in order to get better forecasts to warn people about impending heavy rainfall. And just finally, I want to highlight the work that we've been doing, such as Allie and myself, in spreading our climate knowledge beyond academia. Following these floods, we were commissioned to write a report for the New South Wales Government inquiry into the floods. We also gave evidence into the Victorian inquiry into the October 22 floods and the Victorian inquiry into climate resilience, not to mention numerous media appearances. it's so important for climate scientists to be working with decision makers in order to improve our country's overall resilience to climate change and weather change. Thank you.
All right, thank you. That was great, Kim. And I believe we're back again to Allie, so please, take it away.
Thank you. Stuck with me for a second time. Okay, thank you. So I want to talk about something a bit different now, and that's weather as a resource. So we think about the weather every day. Do we take an umbrella with us when we go out? Do I need to pack a jacket? Hasn't rained in a few days. Do I need to water my garden? Should I be playing that cricket match this weekend when the forecast is supposed to get above 40 degrees? We make decisions every day based on weather. But typically when we look at the decisions we make, we base these decisions on the risk that weather has to us. So this is around the negative impacts and what we can do to mitigate that risk. But increasingly, we're thinking about the fact that weather also provides value. From generating electricity, to growing our food, to even thinking about where we should go on a nice beach holiday. But you might think, well, hang on a second, Allie, that's climate, that's not weather. Right? Well, let's take a step back and think about the difference between the two. And I'm going to use the example of this lovely beach holiday. Let's think about the Great Ocean Road. I'm sure many of you have been to the Great Ocean Road before. Maybe you have your summer holidays down there. So what this is each of these little purple tiles popping up on the screen right now represent the maximum temperature on a summer day. This is actually from Aries Inlet. So this is from the weather station in Aries Inlet. So every day is a different temperature. Sometimes it's hot, sometimes it's cold. We build these up, and every time we count one of those days, we build it up and up and up. And it turns into this grey line if we do this over many years, which is called a distribution, this bell curve. I'm sure many of you have seen them before. And that's what we call our climate. So when we think about climate, we often think about statistics like averages. And I talked in that first talk about global mean temperature or average temperature, right? So the typical summer maximum temperature at Aries Inlet's 23 degrees. We might also talk about the extremes. For example, the hottest temperature on record's 45.1, and the coldest for a summer day is a very brisk 13.5 degrees. But when you think about the value that you take from your beach holiday when you go down there in January, are you going to be thinking about the averages? No. You're going to be thinking about what the weather was like when you were there. And I'm going to guess that most of you in this room, if not all of you, would place much more value on a holiday where you had clear sunny conditions, calm winds, and warm temperatures than you would if it was the cooler temperatures in the high teens, maybe a bit windy, showers coming through, and very cloudy. The value that you place on your well-being in that holiday would be different. And it would be different because of the weather. This is the same climate, but the weather is different. And so weather makes the climate. But it is that sequencing of one warm day after another, or going from warm to cold, or unfortunately multiple cold days, as seems to be my luck whenever I go down to the Great Ocean Road. It's that makes the weather, as well as thinking about multiple variables at once. So not only temperature, is it sunny? Is it raining? Is it windy? And it's that weather that makes the climate. So when we think about weather, actually, I hope I've made the argument to you that we can think about it as a natural resource. After all, when we think about other natural resources, like water, for example, they're just elements of the natural environment that add value to particular systems, economic systems, social systems, environmental systems, and the weather does just that. But of course, increasingly, we're thinking about the weather as a resource as we're moving into a world where we are more reliant on the weather than ever. Let's take wind power as an example. So this is from a paper that was undertaken by researchers in the School of Earth, Atmosphere and Environment last year. And they looked at scoping wind power as nighttime baseload power. Sun doesn't shine at night, we need something to take the baseload. The wind usually drops off at night, but not always. So what can we think about with wind as baseload power? And what they had a look at was how correlated wind in different parts of Australia was. And that's what this map up the top here shows. Basically, each of those blobs of colour show areas where the wind changes in some sort of coherent way. So in other words, if we take this pink area on the southeast coast, if a wind farm up in the north of that area experiences low wind speeds on a particular night, it's likely that those on the south coast will also experience that. And so we can use this information because this information can give us an idea about distributed risk. If we want baseload power that is consistent and constant, we want to make sure that we iron out those times where we have either no wind or too much wind, and they also have to shut those wind turbines down where there's too much wind as well. But on this map, you can also see the black dots. Those black dots are the current locations of wind farms, and most of them are all located in the same area. So that risk is not distributed at the moment. But we can use information about the weather to perhaps give an idea of where it could be distributed. And so this distribution is shown in the bottom graph here, which is a time series of wind power from 1980 to 2023. Now, one interesting thing that comes from this is that wind power goes up and down a lot every year. But what I want you to concentrate on is this kind of light green coloured O plus P and then this dark green CP here. The O plus P is the current configuration of wind farms. The CP is kind of an optimised configuration of wind farms. And what you can see is that compared to the other ones, the dark green, the fluctuations are dampened because you're distributing that risk. So we can use information about these resources to give us a better idea of where to put these wind farms. But of course, I've just shown you how weather brings opportunities, right? But weather also brings challenges, particularly around the challenge of climate change. I spoke in the first talk about how climate change is weather change, and the weather will change. But we need to consider that when we're also talking about how we think about our weather resources. So one of the big questions for the Centre of Excellence is how will our weather resources change? And this paper by colleagues who are also in the centre from the University of New South Wales shows changes to wind power, extractable wind power, into the future in the near term on the left here and in the far term 40 to 50 years from now on the right. This is just from 4 climate models, but basically the blue area shows areas where we have a reduction in that extractable wind power. And the crosshatches show where that is a significant reduction. Small, but significant. We depend on the weather now more than ever, and perhaps more than any other time in history as we move towards a greener future full of renewables. But of course, we also have more capacity to understand those weather resources, and that's a focus for the new Centre of Excellence. So at the Centre of Excellence, what we want to do is look at Australia's weather resources, from energy to food, and even to things like tourism, wellbeing, transport. And we want to understand how they're going to change in the future for the betterment of everybody. Thank you.
All right, thank you, everyone. Thank you to our two great speakers. We've got about 20 minutes or so for a Q&A, which I think will be great. So we'll take questions from the audience in a moment, but I might just kick things off with a couple of questions, if that's all right, that I thought of as I was watching your fantastic presentations. So the first one I have is for Kim. So Dr. Reid, Dr. Reid, so professional. Kim? Yeah, can you tell us a little bit more about the factors that turn a regular weather event into an extreme weather event, and whether we can we say anything about those factors in climate change?
Yeah, absolutely. So what was quite interesting about the meteorological setup is that we see this quite regularly. Every few weeks or so we get a similar setup, but the difference, I guess, is so for example, that blocking high was there for 3.5 days, whereas there was a similar event in April which caused heavy rainfall in Sydney but not quite extreme rainfall, and that blocking high was there for maybe 1.5 to 2 days. So even though if you looked at a weather map you would have a similar setup, it's those small differences in things like the duration of how long that weather system gets stuck there that can really be the difference between a damp day that's a bit annoying and a disastrous flood. On top of that, when the event occurs, so the fact that this event occurred after we'd already had quite a wet year in 2021, so dams and rivers were already full, meant that had this event occurred after a drought, for example, it would have been quite welcome, but because everything was already wet and full, it meant that the impacts were a lot stronger. Another factor is that the river in Lismore peaked at about 3 a.m. Had that been 3 p.m., then the impacts on the people might have been a lot more reduced. So it is unfortunately a case of all these factors coming together at the same time to create a perfect storm, and that really is the difference between a nuisance and a severe weather event.
Thank you, really interesting. And I have another question for Allie. You used a couple of terms that are kind of probably new to a lot of people in the room, but also are kind of new, I think, even in the vernacular of climate scientists. So can you say a little bit more about what you mean by weather resources and an example of what sort of an extreme situation in weather resources is, and what that has to do with weather change, which is new terminology to people who are used to thinking and talking about climate change? How do they differ?
Yeah, absolutely. So let's start with the weather resources one. I think the concept of weather resources that we're thinking of in this new centre is simply what I was talking about before, anything that adds value, really. And that can be a wide variety of applications. So in that sense, we're actually also looking for the opportunities here, not just the risks. But of course, there are risks to the weather resources as well. And that brings in this concept of weather change. And so I think, as you say, we've always talked about this concept of climate change, right? But that's kind of taking the bell curve. That kind of often looks at things in a very narrow way. Averages, extremes, but there are a whole bunch of parts of that distribution of either the single distribution of temperature or what we call multivariate distributions that take into account multiple different variables. They all interact in very different ways and have different consequences for what we feel on the ground. And that's what we're trying to get at with the weather change, is not just the averages, not just the extremes, but all the other bits in between, which actually can have significant impacts. I'll just give you one example, is fog. Fog's pretty boring. Most people don't care about fog, but the aviation industry cares about fog. The transport industry cares about fog. And so looking at things like that and looking at things like fair weather days and things like that is something that we really have a focus on in this new centre, because it's more than just the averages and it's more than just the extremes.
Really interesting. Yeah, you touched briefly on days when there's low wind, and obviously that would be a big problem for renewable energy. Not a very exciting picture in the newspaper of a calm, sunny day, but could be a very dramatic thing in the future.
Yeah, absolutely. So one of the big things that, for example, energy companies are quite interested in are these things called wind droughts. And not only are they interested in wind droughts, one of the, I don't want to call it a side effect, but a co-occurring event that sometimes happens with wind droughts is a heat wave. And so all of a sudden, you have a drop in supply and a huge increase in demand. And so when you have those two things together, that's a problem. So perhaps not a very exciting, from the point of view of a no wind, we'd probably consider that to be a rather nice day. But if everybody's turning on their air conditioners, it becomes a problem very quickly, especially when we become more reliant on renewable resources as we move forward.
Super interesting. Thank you very much. I'm opening it up to you guys for your questions. And
Professor Allie, my name's Paul. I had a question about drought and the likelihood of another drought similar to the one I experienced as a child, the Millennium Drought. How likely is it that we'll experience something as severe or more severe than that within my lifetime, let's say in the next 50 years or so? And what sort of research is Monash doing, if any, about drought resilience? Thanks.
Yeah, that's a great question. So I think the answer of whether we'll experience another one of those in our lifetime is a very difficult one to answer because of the reasons that I spoke about in the first talk, that granular information is hard to come by. But there is evidence that we will get, I suppose, longer droughts or more time spent in drought in southern Australia. We see this a lot already in the southwest of the country. They're kind of in a perpetual drought now. And there is evidence in the southeast, particularly with reductions in wintertime rainfall that we're experiencing here in Victoria, for example, that points towards a likely increase in drought. But drought's a very complicated beast, and the other aspect of this is kind of gets back to this idea of weather, right? So I mentioned in my talk, my research group's actually been looking at the role of weather in drought. And we've found some really interesting stuff, and that is that droughts are made and broken by these heavy rainfall events. You get 2 weeks' worth of these heavy rainfall events in a year and you're in a wet year. You get 1 week's worth of these heavy rainfall events, you're in a drought. And that's because those heavy rainfall events account for most of the rainfall that we get in the year. So it kind of comes down to how those change, right? If we know about those, we know about droughts. And at the moment, we haven't quite got to looking at those yet. We're hoping to do so in the new centre. But yeah, in terms of drought resilience, I think that's something that will be an area of focus for southern Australia. But for the rest of Australia, I think it's a difficult question to answer because we actually don't really know the sign of the rainfall change for some parts of eastern Australia. But I would say we will still get droughts no matter what. So we better be resilient towards them. Yep.
Paul Graham, Bureau of Meteorology. I hope this is not too much of a left-of-field question, but I'm interested to know what your thoughts or opinions are on geoengineering to mitigate against the worst effects of climate change. And I believe that a consensus, perhaps, of climate change scientists are not really in favour of it. But what say we are on the worst trajectory? And also, I'm thinking that climate change in itself is kind of like geoengineering. In a way, we're adding CO2 into the atmosphere, so we're artificially altering the climate. So, yeah, I'm just interested to know what your thoughts are and if you've considered this.
I don't mind.
Yeah, my views towards geoengineering are that we have a solution for climate change. We know that what we have to do is reduce our emissions to net zero. And geoengineering feels like we're sort of throwing possible untested ideas at this problem when we already have a really nice solution right here. And I feel like it's a bit of a distraction and potentially an excuse to emit more instead of dealing with the main cause. The other issue is geoengineering, such as adding sulfur to the stratosphere, could have a whole lot of unintended consequences that we don't know yet. And I think we have to be really cautious. We've already changed the climate. Let's not try and change it anymore, is my personal opinion. You might differ.
Yeah, so I have a similar response to Kim. I think that word unintended consequences is a big one. I am also aware that the technological practicalities of this means that when we come up with these solutions, the time to proper implementation, to even get places to agree, I mean, this is a global problem. It requires a global solution. We haven't come up with a global solution yet for just reducing emissions and doing what we can, let alone geoengineering. And I think the timescales are too long. That's my personal opinion. And the other aspect is exactly what Kim spoke about, unintended consequences. I do recall a talk that we had in our department a couple of years ago where someone actually did some modelling on this, and they looked at, it was something to do with changing cloud properties anyway. But the modelling that they showed was that the response of the atmosphere in the warming phase and then coming back down in the cooling phase, you actually didn't end up at the same spot. It wasn't that you could just reverse. There were still changes in, they were looking specifically at rainfall, that were very different to where you started, even though you'd come back to the same cooling. So I think it's a big can of worms, and we don't need to open it.
Thank you, Rose. I think we've got a question over there
too. That's right.
You go.
We'll go that one first, and then this one next. Yep.
Dr. Reid, Professor Gallant, thank you for your presentation tonight. Here, I'm Tommaso Mattiapareto from Climate Work Center. Question mostly regarding the last presentation from Professor Gallant on, we've seen now that we have more modern models, so we can assess better and evaluate better where we could position renewable energy developments. And I was wondering whether your input, your research input, will influence, or if has already influenced the renewable energy zones that were proposed in the IMO ISP. Thank you.
So I would like to think we have some influence, but I'm not sure in reality what that will be. Look, we are working with partners. We're working with the government. We have been talking to renewable energy companies. We have one energy company who is actually a partner for us, and we will be asking these types of questions. I suppose the amount of impact we would actually have, we will see, but we certainly intend to be doing the fundamental research that will help inform and best inform those types of decisions, yes.
To the side of the room.
G'day. My name's Pat from GHD. I'm interested, you mentioned, and I can't remember, I think it was Allie, you spoke about the climate change risk disclosures that organisations are required to do. Mm-hmm. And you also mentioned about this really fine-scale climate modelling. Mm-hmm. Now, presumably that really fine-scale modelling will be the evidence that these organisations will be wanting to rely on with inherent uncertainty. So who owns that risk? Who owns the risk of climate disclosures, industry, government, climate risk disclosures when there are, I guess, investment? So is it a government-owned information source that is government owns risk, industry take the risk? What are your thoughts?
Yeah, look, I think it's a really interesting question. And I should say this is already happening. And the interesting part of this is that we sit there and go every day because we see new AI models constantly coming out that claim to have building scale projections of the climate with precise, evidence of changes into the future. And as climate scientists, we know that that is utter, I'm not going to say that word. It's just not possible. It's not possible without having large uncertainty bounds, right? The question to who owned the risk, I'll leave that one to the lawyers. But I think it's an interesting point you raise, and I think the best we can do as climate scientists is be as best informed as we can and be very transparent about what these things show. And ultimately it will be up to organisations to make decisions based on what we hope will be very transparent data. I don't know if Kim wants to add anything to that.
I would just add, yes, I bought my first house a couple of years ago, and there are companies offering highly detailed reports on my individual unit for how the risk from extreme weather for my individual unit for about $100. But thankfully I'm a climate scientist, and I know that our scientific models aren't good enough to give that level of information at that suburb or house by house scale. We can make quite general projections about what might happen over Victoria, and I would recommend that if you're making risk assessments, look at the publicly available IPCC data, because that's the cutting edge of scientific research, and all these extra high detailed information that people might try and sell you hasn't necessarily passed the climate science pub test. The best available information is already publicly available, is the point I would like to make.
Thank you. My name's David. Thank you very much to all the presenters. A lot of the information we received tonight is about atmospheric science. There's considerable evidence that the ocean temperatures and the drivers of climate are very, very significant, particularly in those things you were talking about earlier, in terms of the rainfall in Queensland and what have you. How much is your organisation doing in looking at that? Because as a scuba diver for the last 50 years, a lot of the stuff I saw in Tasmania in 1979 has gone because the water is at least 1.2 degrees warmer.
Great question. So we have quite a significant part of our centre devoted to looking at the role of the ocean and its impact on the atmosphere and its impact on the weather systems, and not only that, the impact of the weather systems on the ocean, because it's a two-way feedback, it's not just one way. So there are three main areas, and in one of those areas, which is circulation change, that involves incorporations of the ocean sciences. And you raise a really good point. You know, even things like El Nino and La Nina have to do with what we call ocean-atmosphere interactions. And, you know, some of the uncertainties in those moving forward, are we heading towards a La Nina world? Are we heading towards an El Nino world? There's still very much open questions that I know Sugata knows a lot about as well.
Not here to give opinions. All right, great. We've got a few more minutes left. We've got about 10 minutes left. So if I could see a show of hands for questions. Yep.
Thanks for your presentation. We've discussed that there's a major focus on the transition to net zero emissions. I'm wondering how applicable or how feasible renewable energy is in developing nations where hundreds of millions of people still actually lack access to electricity and basic resources.
Yeah, I think that's a really good question. Probably not one that we can answer in too much detail, but I think the reality of it is that most of the world's emissions come from Western nations, the vast majority. The vast majority actually come from just a handful of companies. I think there is definitely a need to move those areas of the world, as you discuss, you know, towards the cleaner forms of energy. You know, we don't want to be building coal-fired power stations, but as to how we do that, I can't answer that. I don't know if Kim wants to add any more.
No, I think it's a bit out of my area of expertise, but there is this push for a just transition so that we take into account so that the countries that haven't had their big industrial revolutions, like those that have before, get their chance to develop as well. And in an ideal world, they would develop with renewable technology built into it, but I think we need a social scientist here to answer that.
Yep.
Thank you, both of you. I've been involved in environmental science one way or another for about 50 years, and I still learnt new stuff today, so thank you very much. And that brings me to the point of what you're talking about is complicated stuff. And my question is about public scientific literacy. we husband's next to me, he's the diver. We're both sort of appalled by the conversations we try to have with people about simple environmental issues. So I guess it's a personal question. How do you balance the need to do the science, in other words, to get involved in these complex data sets and the modelling and so on that goes on, and your need, I think as Kim said, to be advocates in decision making? It's a conflict, and it must mean you have to make decisions about where to put your energy. But at the moment, we have an increasingly, I think, ignorant society, and that is going to be one of the worst things about mitigating climate change. Sorry for sounding a bit negative.
Yes, so I don't think they're here today, but our comms manager was going to attend. So part of the centre, which is different from earlier iterations from these centres of excellence from a few years ago, is that we have dedicated comms people we have about 5 or 6 people whose full-time job is to share this science with the non-scientists. Allie and I both do quite a lot of communication, and I think one of the benefits of working in a large centre is you have people who are brilliant at coding and brilliant at doing the technical stuff, and they can work on that a lot more. And we can go talk to the media and come to events like this and do our communication. And it is a balancing act. I'm not sure what the perfect ratio is, but personally I find it really important and rewarding to talk to people and see their eyes change when they understand a concept. I think is really important. And just the more you say, we call this sort of inoculating people, which Allie can talk about, but the more you repeat this information about climate change, hopefully people will slowly understand it, and we just have to keep doing it. Do you want to add on to that?
Yeah, just to add to that, I think there's a really strong role for working with social scientists here. If I've learnt anything in the past 5 to 10 years that I've been doing a lot of communications, is that literacy actually doesn't do much. People's ideologies around this stuff are so strong, and it's that influences their decision making, not literacy. The evidence would actually say it's not. The evidence would mostly say that it's down to ideology. And so I think there's a really strong role for working with social scientists to do this stuff.
One question is, I read that the sunspots on the sun, which they call solar winds, how does that affect the environmental winds, which I think it does, by NASA? And the second thing, I was at at another conference where they were saying that there are volcanoes, and also if you go to most parts of the world where they burn the sugar cane, which is still common practice in Indonesia, Malaysia, and Australia, is causing more than what we say the factories. So that's the two-phase question.
So as to the emissions, fossil fuels, there is no question that fossil fuel emissions are the biggest source of emissions. That has been shown time and time and time again. That's not to say that land use changes and burning and things like volcanoes don't produce it as well. Of course they do, they contribute. But we don't get big volcanoes going off very often the amount of fossil fuels dwarfs that. Sunspots, I know there has been some, let's call it research that's been done in the last little while, I suppose, in the last few decades, that has described influences on the climate. But when that has stood up to scrutiny with other scientists, I'm not sure that has been a particularly robust finding. So my understanding is that sunspots have not been shown to be that influential.
I think you were asking about winds?
No, the solar winds, because they say Narsey was saying that sunspot changing and the solar winds supposed to be.
Oh, the solar winds, okay, yeah. I think that's more upper atmosphere though.
Yeah, so
Yeah.
we've seen a lot of aurora activity lately because the sun has been quite active, but closer down to where we are, the temperatures are definitely controlled by what's in the lower atmosphere.
Sorry, I misunderstood your question.
Hi there. Just want to say thank you very much for your talk. So I've learned a lot from that. Just another follow-up on renewables. I was wondering, with the modelling you're doing with the areas of wind that change during nighttime, are you working with energy companies to identify, as the climate changes or weather changes, are there certain types of renewables that stand out as the most effective one as the climate changes? So maybe if wind is going to be more variable, is it better to go with other options, or
So that is an active area of research. We don't know the answer to that yet. We are working, so one of our partners is Energy Australia, which is one of the big retailers and producers. And we will be working with them on such questions. We hope to perhaps work with other energy companies too. It was just they're the ones that came to the party first. But yeah, questions like that are exactly what we want to ask, but the centre was only opened a few months ago, so we haven't had an opportunity to do that yet. But yes, that is certainly where we want to go.
And I think fundamentally the answer will be a mixture. We talked about wind droughts being a problem for wind energy production, but that's a great situation for solar energy production. So having a mixture that can sort of counter these risks is, I think, what the final answer will be.
Distributed risk.
Diversify.
Right. Thank you very much, guys. Fantastic presentations, fantastic questions, and fantastic answers. So please give our speakers and yourselves a round of applause. All right, that brings us to the end. I'll hand over to Udi now. Thanks.
Again, a final thank you to the presenters. I'm sure there's lots of food for thought for the members of our audience. So I'd like to say, give you guys a thank you gift and just say thank you once again for their time. Okay, so that brings us to the last bit of this session. I won't, rattle on for too long. Basically, since we've got all our alumni in a room, I just want to share what's been happening in the alumni land, so that you're across the different things and also potential benefits, etc., that's available to alumni, all that. So I know Professor Jordan Nash, he gave a bit of an update on the numbers, but I do want to touch on that this year we've launched a biannual alumni newsletter. So it includes resources for just listening to up-to-date research, stories of our alumni community where you can find people that you can connect with, and also there's much more opportunities such as coming to events, webinars, etc., that is in that newsletter. So right now we have about 10,000 alumni readership, but hopefully, if you haven't had a chance to read it, certainly do tune in. And in terms of the alumni that get connected through events, etc., we currently have about 13,000 alumni who do that, including all of you that's attending here. So hopefully, the hope is for next year for us to have many more of these events, and also the webinar series that we do will continue so that you can continue to hear and learn from the faculty. I can see there's a number of volunteers in this room who have assisted us through mentoring, guest speaking, connecting us to industry, etc. So, and also some of the donors who have supported us philanthropically. So I'd like to actually just say a heartfelt thank you, because your support is critical and you have helped a lot of our students. So I just want to say a sincere thank you for making the time to be here today as well. Okay. I don't know if anyone of you know what benefits you get as being a part of Monash Science Alumni. So I thought I'll just touch on a couple and then actually put in a link so that you can go away and have a read through. So there's certainly, if you're interested in studying, there's postgraduate discounts, but also there is a benefits of, for example, library access, and also other corporate discounts, etc., that you can take advantage of. So certainly scan this QR code and just check on as to if there's anything that's interesting, because I don't think many of you know that we offer that. So I just want you to know. And certainly connect us through our LinkedIn group. It's the first place that we actually put in any of the events, etc., that's coming, for our alumni on. So join there. It is a group which actually allows you to reach out to some of the alumni and make connections. So it's a great platform for you to connect. If you see a fellow alum, if you're going for an interview in a company, you can see someone that you can connect with, reach out, and I'm sure that most of the people will be happy to guide your way through. Okay, so before we go into the networking session, I'd like to probably introduce some of the faculty members that are present here today. So if you've got any questions or if there's anything else that you want to ask, certainly during the networking session, you feel free to do so. So if you're interested in volunteering, mentoring, etc., please do come and speak to me. And if you're interested in supporting philanthropically, speak to my colleague Emma Moore, who's waving over there, and you can, she will update you on anything that you need. We also have Fiona Broussard, who is our Senior Business Development Manager, and she basically connects organizations with the research that we are doing within the faculty. And in terms of some of the academics who are present here today, we've got representatives from the different schools. So we've got the heads of school, so Head of School of Earth, Atmosphere and Environment, Professor Andrew McIntosh. So if you'd like to speak to him about what's happening in that space. We also have Professor Craig White, Head of School of Biological Sciences. And we also have Professor Daniel Price over there, School of Physics. So if there's any questions, or if you're an alum from those particular schools, you end up doing a major in that space, please do speak to them. And also we've got the Associate Deans, so Kristen Merth, Associate Professor, she's the Associate Dean for Equity, Diversity and Inclusion, and Professor Pete Betts, who is the Associate Dean for Graduate Research. So, in case you have any questions, you can continue those conversations with our presenters in the networking session, and that brings us to the end. So I'd like to say a couple of thank yous, and then I'll let you all enjoy this evening. So a big thank you once again to our presenters today. Allie, thank you for taking over Christians as well in such short notice, and Sugata and Reid as well. And also some of the staff who are here today and who helped this event, help us set up this event to come together. So I'd like to say a huge thank you to them. And lastly, I'd like to thank all of you for being a fantastic audience. And I hope that the conversations continue outside. And on your way, please do stop in for a photograph, for a group photo down in the stairs. And hopefully you enjoy the night. So thank you.